On page 95. So number 60 on page, what was it? 95, number 60. So 60, suppose you're playing a yo-yo as shown to the right. Sketch the graph of what h of t to show the height h of the yo-yo above the floor over time. At t equals 0, the yo-yo leaves your hand. So if I was graphing this, nothing really fancy here. The first part of this graph says, okay, at t equals 0, it starts at 3. And what happens to the yo-yo is it goes down, comes back up to 3, goes back down, goes back up to 3, and so on, right? That's all they're asking for on that question. It goes back up and down, up and down. Yo-yo, if you know how to play with the yo-yo, it just goes back and forth, right? After a while, it should shorten up a little bit, maybe a little bit, but nothing major. Part B, that's all we have to do in part A. Part B, should your graph be that of a function? Is it a graph? Remember, a vertical line test tells me a function. At any x value, is it going to be at more than one height? No. At any time? Is it at more than one height? No, it's only at one height at every time, right? So this is a function because, I mean, there's a couple ways to think about it. Every x value I have, my graph is diagonal. Every x value, I only have one value, right? If you drew a vertical line down, it only touches once, so it is a function. You can use a vertical line test very easily to decide that. C, suppose you demonstrate your yo-yo ability on an auditorium stage that is 5 feet above the floor. Describe the translation of the graph h of t that represents the height of the yo-yo above the auditorium floor. Yeah. Yeah, you know, so this one starts at 3 because that's where I'm starting from, right? Now, if I take my body and move it on the stage 5 feet higher, what happens is it moves it up 5 more feet, right? So now it's starting at 8 units, right? Is the shape of the graph going to change any? Is it still going to go down and up the same way? Yeah. The only thing is the whole graph moves up 5 units. That's all it is, the translation of up 5 units. And then part D, choose the function g of t that represents the height of the yo-yo above the auditorium floor when you are on stage C, or on the stage. Which of those equations is going to move the graph up 5 units? Let's start with A. What does A do?
Moves it left 5 units.
A is going to move it left 5 units, right? Because it's inside the parentheses. So is that the one we want? B moves it to the right 5 units. D moves it down 5 units, and then C, which is the plus 5 at the end, is going to take my whole graph and move it up 5 units. So the one I want is C on there. Questions on that? Okay. 57? Okay. Okay. Transformation, okay. Graph each pair of functions in the same coordinate plane, okay, and describe the translation that takes the first function to the second function, okay? So let's just go here. I'm going to do it. Here's my graph. Let's graph the first one. Let's talk about the first function. The first function is an absolute value graph, correct? Everybody agree with that? Absolute value graph is a V. Everybody should know that. It's a V. On here, what's my slope on this one? 1, because the 1 in front of the x, right? Well, what happens to my graph overall? It moves it up 3 units. So I'm going to start at the original 0, 0. I'm going to move at 3 units. This is my parent function moving up 3 units. You told me my slope is 1. Up 1 over 1. Here's my graph, and this is y is equal to absolute value of x plus 3. Okay, that's my first equation, correct? Now my second equation, what happens on that graph? It's moving to the right 4 units. The x minus 4, what makes it 0? Positive 4, right? So I'm going to move it to the right 4 units. So I'm gonna go over 4 units. I'm gonna put this one in purple. Did I move up or down any? On this one? What's my slope of it? What's the number in front of the x? 1. So the slope is still 1, so I'm gonna go up 1 over 1. So there's my graph. So this is y is equal to absolute value of x minus 4. Okay? Now I graphed both equations. Now the question wasn't to graph them, it kind of was to graph them. The second part of the equation says, what's my transformation to go from the first graph to the second graph? So let's talk about what happened. This graph, here's my first graph. Here's my first graph. We went down and then over, correct? So if I was what my transformation would be, it's a vertical or vertical down. Let's go down first. Vertical down. Vertical translation of a negative what? Negative 3. Vertical translation of a negative 3. So I might write that down here. Say vertical of a negative 3 and a horizontal. We moved it over how many units? 4, and the horizontal of plus 4, moving to the right 4 for positive 4. Does that make sense? To go from one to the other.
We also like a diagonal, it says.
Oh, you could go a diagonal translation, you could say, because it goes down one row. If you were saying diagonal, then, well, I would know it's diagonal, but I still would figure it down 3 over 4. Okay? Go ahead.
Diagonal, is that just negative 3 over 4?
I just say diagonal, I still would put in the vertical and horizontal in there. Okay. One of the things I want to mention though, in state testing wise, I haven't seen the word diagonal too often. I usually see the word, or maybe on the state ACT, I see the word oblique instead of that. So if you see oblique, O-B-L-I-Q-U-E, that's the same thing as diagonal. Okay. Another word, they don't use all the same terms in every book, and any word they use here is oblique most often. Okay? What up?
45 on page
102, number 45. Anybody have any questions? 42, you think?
45.
45. What? Okay, 45, we got Sundays and cones, and each one is one each, they say on here. So what we have here is this, on 45, and I'm going to write down what they have. C stands for cones. S stands for Sundays. And what we're going to do here is, it says, first equation says, write the equation for the amount of scoops of ice cream in my cones and sundaes. So, in other words, each cone takes how many scoops of ice cream? 1, and each sundae takes how many scoops of ice cream? 1. So therefore, part A here, very easily, the number of scoops of ice cream in the sundaes and cones are going to be just C plus S. Cones and sundaes. Cones and sundaes is C plus S. Number of cones plus the number of sundaes tell me how many scoops of ice cream, right? Now part B says, suppose you have enough yogurt for 200, I guess it's not ice cream, it's yogurt. Yogurt for 200 scoops. Write inequality represents all possible combinations of cones and sundaes. So if I have 200 scoops, possibility, what does C plus S have to be? Less than or equal to 200. Because this is the total scoops we have. So C plus S has to be less than 200. I cannot make more cones and sundaes than I have scoops of ice cream. So that has to be less than or equal to 200. It can be equal to, and it has to be less than. Now to graph this, what I did, and I always tell people, well, C and S aren't the variables I usually deal with. I usually deal with X and Y. And what I always did, well, let's just go up here and say, well, X is going to be my X-axis, S is going to be my Y-axis. Let's put a little note to myself how to do it.
It'd be any different if C was Y and S was X.
Your graph would not look any different. On some graphs it would, and that's why I want you to label that way. Well, but on this graph it wouldn't be, because they're both 1 and 1 here. So So now if I was graphing this one, now there's a couple ways of graphing this. I'm going to put over here, here's my cones, here's my Sundays, I'm going to label my axes, C and S. And now, as I go through here, what I'm going to look at is set up my scale. Now what I might do is this. You could get variable by itself, or I can do my X and Y intercepts. And that's probably the easiest way to do this. So in other words, if S was 0, S is 0 is right here, correct? Where would it cross this axis? If S was 0, what would C have to be? What's left? C would be, if S was 0, put 0 in there, 200, correct? What plus 0 is 200? 200, right? So if S is 0, I'm just going to go over here, make a scale. Here's 200. Yeah, I'm going to put my scale here, like that. Now the other way, if C was 0, now C is 0 is right here, right? If C is 0, what's S? 200. I'm going to use my X and Y intercepts very easily here to graph this equation. So I'm going to have my 2 points. Now when I graph this equation, first of all, is it equal? So I'm going to have a solid line. But I'm going to stop in the first quadrant. I'm not going to extend my line. Can't have negative cones, it can't have negative Sundays, right? If X stands for my cones and Y stands for my Sundays, can I have negative values? Yeah, they only can reach 200, so all that. Now I do have the shade. Now how do I determine what side to shade?
So you know
Yeah,
it can't be more equal to 200.
Yeah, it can't be more than 200. It has to be less than. I always try a point. Now the easy point to try right here is 0, 0, right? 0 plus 0 is? 0 is less than 200. Is that true? Now when I shade, I'll be careful. I'm only going to shade where it works, the first quadrant. I'm shade in the first quadrant. So that's the only area. I don't go into the second quadrant. I don't go into the third quadrant. All over the place. I just only work in an area that makes sense on the problem. Now the problem says part C, still, it says graph the equation, and then it says, I believe it says, is 2075 a solution or something like that, 2050 a solution to the equation? Well, if I go over 20 and up to 50, is that a solution to my equation?
Yeah.
Yeah, it's a solution. I can sell 20 cones and it's 50 Sundays, and it shouldn't be a problem because I have 200 scoops, right? Now, part D says, on your graph, fill in a point that represents 60 coins and as many Sundays as possible. What does the S value point represent? So if I was at 60, my graph's a little bit off here, but if I was at 60, my graph would be right about here, would say. How many Sundays, 60 would stand for the number of cones, right? How many Sundays would there be? 140. Because why? You subtract 60 from 200, it has to be 200, right? So how many, what does the 140 stand for? 140 Sundays, right? And that's what part D asks us, is what if I go up on my graph to the line, what does that stand for? Okay. That's all it's asking you on part D there. Okay. Next one. Okay, 48 on the calculator, running the calculator. We're going to graph this one here, and it says graph y is greater than absolute value of x plus absolute value of x plus 3. I'm going to go to graphs. I started a new document. The first thing we're going to do is we're going to graph this equation. We're going to have to get the less than or greater than symbol in there. You know, and a lot of you use, I don't know how you typed it in. One of the things I want to point out now is, you notice right now it says f of x, right? F of x means it's a function. Okay. First thing I want you to do is hit delete or hit clear. Once you hit the clear button, you'll see all your less than, greater than, less than, and go through all those symbols come up. You want to get that? On this one, I believe it's 48 is greater than, right? So we're going to type in the greater than symbol. Once I hit that symbol, you'll notice it changes to a Y. Y.
It's not a function really anymore.
It's not a function anymore. Think about it. If you're shading that area of the graph, is it a function? No, it touches more than one spot. So the calculator knows that. It's not a function anymore. The only time I deal with F is when it's a function. Now, to type in absolute value, what I'm going to do is this. I'm going to use the word ABS, absolute value, X, plus ABS, X plus 3. ABS tells the calculator its absolute value. There is a button you don't dig for it. It's almost easier for typing ABS. And I should get my graph. Flat between, where we talked about this the other day, when we talked about what makes it 0. Absolute value of X is 0, right? Absolute value of X plus 3 is a negative 3. You know, we talked about that, and you'll look at this graph, and negative 3 to 0. It's flatline, right? Those 2 points. It goes up to 3 in those. And then the 2 graphs off to the side. So the graph on the calculator. Just think of the ABS, you have to remember the different options of that. So, and if I was making a table and I had a graph that's on a sheet of paper and graph points, what I might do is go to menu, view, show table now. Oh, again, on here, I guess I can't say, on here I can't show a table when it's less than or equal to. Because of the fact that, because at that one point you have a whole bunch of points, don't you? So we won't have a table. So.
I have a question. If, like, say the x was a 2x on one,
Yeah.
so it's just 2x plus x plus 3, then would the slope on that side be 2 over 1, and the slope on the other side be 1 over 1?
It would be different. Let's just check it here. I'm just going to go back and do that one real quick. You're saying like if this was 2 here?
Yeah.
Oops. It changes up a little bit because when we do that, because you notice there's 3 equations now, you got one a little angle, another angle. Because when we did that piecewise function the other day, what happened is when you did both negatives, the x's cancel off. One negative, one positive, both x's cancel off, correct? Now, when one's 2x and one's x, will the x's ever cancel off? No, so that's why there's another line. It's not a flat line, there's a line between, but it's not going to be flat. There's no way for the x's to cancel off. So it's kind of a different looking graph. So we can get a lot of different looking graphs.
Is there any way you could have a flat line with a slope on this side that's different than the slope on that side?
Could you have that? Probably not. It'd be very tough to do. Okay, what else? Keep going with questions. Or what? On the same page? We have to do 46? Oh, right, okay, good. When you graph an inequality, you can often use the point 0, 0 to test which side of the boundary line is shaded. Describe a situation in which you could not use 0, 0 as the test point. That's the main thing. When I graph the equation, like if I was graphing this equation, let's say I come up with the equation, and I'm just going to throw it here, and I wanted to shape, and my graph went something like this, okay? And I wanted to know which side of the line to shade on, right? My graph goes through 0, 0, so I could not use that as a test point. Well, then what I would use is I use a point above there, maybe 0, 1, or a point inside here, somewhere where the graph is not. And that's the only case where you would not use 0, 0. I don't use 0, 0 if it goes through the graph. You would not do that. You know when to use 0 dotted lines and solid lines?
The solid lines go from 0 to 2.
Greater than or solid lines, or dotted lines is the less than or equal to, right? Not less than. Dotted lines is just less than or greater than. There's no equal sign, and then greater than or equal to or less than or equal to is solid. Okay. And I know that when the book talks about, well, sometimes, like if I was graph, what's this graph one, for example? What's graph number 18? I think we gotta do that one. You know, I do this kind of a little different than the book does it. And I'll explain why. I don't like, one of the things when I teach this, let me write down the equation first. 1 minus y is less than or equal to. I believe that's the equation.
There's no absolute value on the 1 minus 1.
Oh, no, that's not okay. One of the things when we do this equation, one of the things that happens a lot of times is when we graph this and get the signs and all this kind of stuff, students have a hard time.
It's not greater than or less than.
Or just one of them? Okay.
Just less than.
Just less than, okay. One of the things that people have a hard time is, remember to flip the sign and all this kind of stuff. Because when you divide by a negative, you flip the sign. Okay? And that changes which side you shade and all that kind of stuff, and all that good stuff, okay? So if I was doing this problem, you know, one of the things, and I'm going to go through here, is, here's my original equation. First, I would probably try to get y by itself. So what would be that first step? Subtract 1. So I'm going to subtract 1 from both sides. So I'm going to get a negative y is less than 2x minus 1 minus 1.
Then you flip the sign and multiply by -1.
Multiply or divide by -1, and you're going to flip the sign. And so I'm going to get y is greater than negative 2x minus 1 plus 1. Okay? So when I divide by negative, I flip the sign. Okay? And what happens now is, what happens a lot of times when students do this is they forget to flip the sign. So I always tell them, don't even worry about that. Don't even worry about it. What I tell them is this. Just treat this as an equal sign. We'll come back to it. If this was an equal sign, what do we know? It's, where's the start? Where's the start? Does it start at 1, 1? It starts at 1. I'll agree the y coordinate 1, but how about this one? 1/2. What makes it 0? What makes it 0? If you don't know that, just go off to the side. I'm going to go 2x minus 1 equals 0. 2x equals 1, divide by 2, so x is equal to 1/2, correct? So I got 1/2 and 1. So I'm going to go over 1/2, up 1. Okay, there's my point. That's where my vertex is. Okay? Now, which way is my graph going? Down what? Down 2 over 1. My slope, right? The 2 in front. Down 2 over 1. Now I'm going to go back to my original equation. Real quick before I do that. My original equation was here, is less than. I don't care what the less than or greater than. Is there an equal sign in there? So is it a dotted line or a solid line? Dotted line. There's no equal sign underneath there. It's a dotted line. So I'm going to go down 2 over 1. Down 2 over 1. Both ways. But now instead of drawing a solid line, I'm just going to draw a dotted line. There's my dotted line. Now to save myself the hassle, say, well, did I flip the sign, or did I not flip the sign, or do I remember flipping the sign? What I'm going to do is go back to my original equation. First of all, let's look at this graph. Can I plug in 0, 0? Maybe. I can't tell for sure if it goes through there, right? So let's just pick a point up here. I'm going to pick the point right here of 0, 1. That's an easy point to pick, right? I picked that point because I know my graph does not go through there. So I'm going to go up here on my original equation and plug in the point 0, 1. 0 is x, y is, so 1 minus 1 is, 0 is less than, x is 0, right? 2 times 0 is? Minus 1 is? Negative 1 absolute value is? 1. Is 0 less than 1? Yes. So I go back and say wherever that point is, that was a true point, so I'm going to shade. Wherever that point is. That's all over the place. I'm going to shade on the outside. Okay? Did I have to worry about flipping the sign? No. I kind of like doing that for now because of the fact that people forget to flip the sign. If they flip this, divide by negative, and forget. Always go back to the original. Don't go back to one you changed. Go back to the original and try your points in. Test that's called. It's called like a number 46. It's called a test value. It's a test value just to see if it works. If you treat it as an equal, get your equation graphed out, dotted lines, outlines, and all that, and then test the value. Question about that. What else? Got 20 minutes. Go ahead.
Number 30 on
30 in the worksheet. Second. Oh. For any equation with slope intercept form a line perpendicular to the graph of the equation that passes through the x-intercept of this line. Okay?
I just don't get how you figure out the x-intercept with those lines.
Okay, the x-intercept is when y is 0.
Okay.
So you plug in 0 for y.
Okay.
And so it's a good question to go through. So first of all, what we're going to do here is we're going to set this equation like this: 2/3 x minus 6. So we're going to add 6 to both sides. We're trying to find our x-intercept. So we got 2/3 x equals 6. So we're going to times by 3/2 on both sides. So I'm going to get x is equal to 18 over 2, which I believe is 9. I solve it down right. 6 times 3 is 18. This would go like this. And 2 times 1 is 2, so 9. So my x-intercept is 9, 0. Okay, so it equals 0, solve it down. Now the question comes in here, it says write an equation of a slope-intercept form of a line perpendicular to the graph of the equation and passes through the x-intercept. So perpendicular, now if I'm going to say perpendicular to 2/3 x minus 6, what would it be? Negative 3/2. Perpendicular is opposite reciprocal, so negative 3/2 we're going to use. Now if I have that, what we're going to do is we're going to set up the equation y minus y1. And we're going to go through here. We've got y minus 0. Negative 3/2 x minus 9. Find our point. Y minus 0 is nice because it's just y. Bringing this through the parentheses, I'm going to get negative 3/2 x plus 27/2. Is that good? Now I want to point out one thing. I see this on yesterday's or 2 days ago quizzes. A lot of people have multiplied by 2 on this equation and got this answer. That is not right. A lot of people do that. That is not right. If you multiply by 2, you have to multiply both sides of the equation. You only multiply one side of the equation. So you wouldn't have 2y on the other side still. You can't do that. So those two are not equivalent. So just beware as you go through this. These two are not equal. You cannot multiply by 2 unless you do it to both sides of the equation. I see that mistake a lot yesterday. Okay. That was a worksheet. Okay, keep going.
Then 69 on the worksheet.
69 on the worksheet. Okay. Farmers market, merchants can rent a small table for $5, a large table for $8.50. One time, 25 small and 10 large were rented. Another time, 25 were rented. Okay, one time, 25 small and 10 large were rented. Okay, then another time 35 small and 12 large were rented. Writing expression to show the total amount of money collected. Okay? It's a couple ways. I guess you can kind of think about this. This is looking at a different expression here. The small tables are $5 a piece, and the large tables are $8.50 a piece, right? Of the small, how many small ones did we rent? Each one, each time. 25 and 35. So we're going to take 5 times 25 plus 35, because that's how many, the first time 25 were rented, the second time was 35 rented, right? This is right an expression, so expression means there's no equation here. And the large table is how many were rented? 10 and 12. Now if we take $8.50 times those and $5 times those, that'll tell you how much money was collected on them. Trying to remember, large tables, large table rented. Now, there's a couple of ways of solving this. So you could do it inside the parentheses first, or you could FOIL it through. Either way works. If I was doing inside the parentheses first, I'm going to get 5 times, looks like 60 here, plus 850 times 22. 5 times 60 is the easy one, is 300. Plus 22 times that would be 176. Plus 20, plus 1187. Is that right?
Yeah.
Ooh, I don't know.
Yeah.
187. And adding those two together would give me 487.
That's it, there's no variable.
No, there was no variance. It's looking for expression, so we're not solving for anything, so we don't need a variable this way.
What are we doing tomorrow?
I'll do it every day. I might plug some check or review, check or test stuff. Is some of you going off of Riverwatch or?
Today.
No. Okay. What else?
Could you do 48 on this?
Same thing, 48? Okay. Illustrate how you can determine whether 2 lines are parallel or perpendicular. Write an equation whose graph is parallel to the line shown in the graph to the right, and with an equation whose graph is perpendicular shown to the graph to the right. Explain the reason. Okay? How can you determine if 2 lines are parallel? Okay? So if I had this equation, now let's say 48, this is this equation, y is equal to 3/2 x minus 1. If I want to write a line that is parallel, I have to write a line that has the same slope but a different. Okay, so what would it be an equation? There's a lot of options here. Y equals 3/2 x to start. Then what?
Just that's it.
That one would work. Plus 6 would work. Plus 5, minus 10, whatever, right? Any of those will work. They'll be parallel because they have the same slope, right? But they have a different y. Y is the second. Now, how do we tell if 2 lines are perpendicular? Opposite reciprocal slope. Now, when I say opposite reciprocal, that means if the slope is 3/2, the other one would be negative 2/3. So I've got negative and positive, right? So if I wanted to write a line like that, I would have y is equal to negative 2/3 x.
And pretty much any number.
Any number, it could be anything. Now, minus 1 I can put in there, doesn't matter. Minus 1, minus 6, minus 5, doesn't matter. Any of those would work as perpendicular. Another way you can tell perpendicular is this. Perpendicular, you can say if you take the 2 slopes and multiply them together, it equals a -1. Then they are perpendicular. You'll see that in a lot of math books. M1 times M2 is equal to 0.
You do 66.
Same page? 66. Okay. You're just simplifying the expression down. Plus m, 13m plus m. Just remember, if there's no number in front of it, it's always a 1. So when you're adding variables, you just add the numbers. You don't add the variables. You don't do anything with the variables. So in other words, on this one, you would have 14m. That's it. That's all we're looking for is simplify the expression. Okay?
Number 6 on this page.
Number 6 on this page, what?
What was that?
Okay, determine whether the lines are parallel, perpendicular. This one would be neither, yeah, because one has a slope of 1/2, one has a slope of 1/3, and one has a slope of negative 1/2, so it would be all neither. Anything else? Hope I don't have work done right now. I hope we get all your grades online today. Tonight. See where we're at. Parent teacher conference is on Monday. So I'm probably going to see some of your parents, I hope. We go through this. Yeah, is so there. It's not big, even close, actually. This is like the third week right now. So it's very close, you know, and so parent teacher conference usually is like our third week before. I think this is the second week next week. So we would have made this week, well, I think only 2 more weeks we would make quarter time. I didn't think about it this way. I know Mr. Slade said 4 weeks from now the all starts. So it ain't very far away. So we got a lot of work to do. Some of you, I read the lesson plan. Wrote the lesson plans. I read your notes from the sub. Some of you are not kicking it down like I hope to. I'll put it this way. Some of you are doing a very good job. Some of you are not. I need you to ask the questions. I need you to get it picked up a little bit. It's not going to go away. You know, and that's the bad thing right now. It's not going to go away.
When is the placement test?
I'm guessing it's going to come up here in the next 2 weeks. I know she talked again in February.
We have some worksheets for that.
If you stop in, I'll show you where stuff is. I have stuff online you can work on. I went to a meeting this week and I want to stress out the point. The meeting was brought up on some of it as a legislature. One person brought up the part of the grad test. You guys are responsible for passing the grad test as it is. 11th grade test next year. One of the things I heard this week, and I'll be honest with you, is this. They said, will the grad test be around much after this year? They said, probably not. But the bad thing is, it's going to be replaced with something. So just because it's going to be gone, doesn't mean you're not going to take a test. What I'm guessing it's going to be replaced by is an end of the course test. In other words, you take a test at the end of Algebra 2. You pass it, you've got to take credit for that class. If not, you take the class over. That's what my guess is going to be replaced by. That's what 47 of the states do right now. So you'll hear rumors that they're getting rid of the grad test. If they get rid of it, it means it's going to get replaced by something. So just don't think, okay, I don't have to worry about it. It's going to be replaced. That was the biggest comment. It's not going to get, it's going to get rid of it, but it's get rid of and replace. So something to think about. And I know you guys are held responsible right now that you have to graduate, pass that test to graduate. So some of you have to pick it up a little bit to make sure we are on the right track right now. You'll hear rumors that you say you get 3 times and you get a fail. I have students on their 7th or 8th time already. They're doing it all year. They're not going to go to another class. They just skip other classes. They have to study outside of school. They're on their 6th or 7th time now. We don't just say 3 times and you're done. We make sure it won't look good in your transcript if you don't pass. So we will try to work hard if you can
get you passed. So I have confidence if you work with me, you know, we will pass it. You have to work with me. If you don't do a lot of your stuff on your own, it's gonna be tough. Okay? So hopefully tomorrow, I'll be honest, I'll have the test ready to go. And tomorrow when you come to class, if there's no questions, we will take the test. Okay? If there's questions, we'll answer questions. So, and I'm hoping to get your rest of your online, most of you did it on Google Docs. I hope to get those good. I got the one class done, I hope to get the rest of the class done this afternoon. We'll see where we're sitting, get those grades in too.
I know it'll do before Friday.
Before Friday, I will take it up. What I've been doing this quarter is, once the test is taken on Friday, I don't grade any corrections, I don't grade any tests afterwards. So, something to think about. So it's a lot to work on. Learn this stuff. You haven't looked through it. I'm gonna ask you questions. I will be around for school quite a bit tonight. Stop in and visit with me. It's fine. Let's see what we can get to do it very well, so I have something nice to show your parents. That'd be really good. So let's see if we can get this all caught up here. And then when we're done with this chapter, we'll be moving on.
Cameron Modal and Justin Kaufman, please come to the office. Cameron Modal and Justin Kaufman.
Bring questions tomorrow, please.